In this video, we will see how we can balance nuclear reactions. There are elements in the periodic table that are not stable and undergo natural radioactive disintegration. When these disintegrations take place, they may give off alpha particles, which is nothing but the helium nucleus. The helium nucleus has 2 protons and 2 neutrons, therefore the atomic number is 2 and the mass number is 4. Sometimes when these disintegrations take place, instead of alpha particles, they produce beta particles or electrons. Electrons have a -1 charge and the mass number is 0. There is a third case where it may produce an electromagnetic radiation instead of an alpha particle or a beta particle. Balancing nuclear equations. In order to balance nuclear reactions, we use mass number and atomic numbers of the reactants and products. Always the sum of the mass numbers of the reactants should be equal to the sum of the mass numbers of the products. That's the first point. And the second one is the sum of the atomic numbers of the reactants should be equal to the sum of the atomic numbers of the products. So having these 2 points in mind, we can actually balance nuclear reactions. Let's look at an example. Here in the following reaction, you'll find on the product side you have an element X, an unknown element. The reactant is plutonium 94 239. The atomic number is 94 and the mass number is 239. It produces an alpha particle or a helium nucleus, which is 2He4. Along with it, it produces a new element, which is X. We need to find out the value of the mass number and the atomic number. A represents the mass number and B represents the atomic number. Since we said the mass number on the left should be equal to the mass number on the right, 239 should be equal to 4 plus A. Or if you solve for A, it will be 239 minus 4, which is going to be 235. Or the mass number of X is going to be 235. Similarly, if you look at the atomic number of plutonium is 94. On the product side, you have 2 products, helium or the alpha particle, which has an atomic number of 2, and the atomic number of the element X is unknown. So we're going to write 94 is equals to 2 plus B. And we're going to solve for B. B is equals to 94 minus 2, which is going to be equal to 92. So now you will look in the periodic table and determine the element. In this case, it's going to be uranium. And so the element that was produced by the alpha decay of plutonium is uranium 92 235. That's how you can determine an unknown product or reactant in a nuclear transmutation reaction or decay reaction. In this case, we will see what the products are or what the new element is produced when there's a beta decay. An electron is represented as -1 E0, where -1 is a charge, 0 is the mass number. Carbon 614 changes into an element X and an electron or a beta particle. So we need to find out the element X. We need to find out the mass number and the atomic number. So like in the previous case, we can first start with the mass number. For the reactants, carbon, the mass number is 14 is equals to A plus 0. A is the mass number of X and 0 is the mass number of the electron. So we can say 14 is equals to A plus 0 or A is equals to 14 minus 0. So the mass number of the unknown element is 14 in this case. Similarly, the atomic number of carbon is 6. On the product side, you have X, where we have assigned the atomic number to be B, and the atomic number or the charge of an electron is -1. So we can say 6 is equals to B plus, in brackets, -1. Or we can say B is equals to 6 minus of -1, which makes it 6 plus 1. Or the atomic number of the element is 7. And if you look in the periodic table, you'll find that The element with atomic number 7 is nitrogen, or we can say carbon 14 undergoes a beta decay to produce nitrogen. So that's how we can determine the element or the subatomic particle that is produced during a nuclear transmutation or a nuclear decay, and come up with the element or the particle. That's it for now.